In Lesson 96, we look at joint and combined variation and more on irrational roots. In the first example, we have the number of girls varied inversely as the number of boys and directly as the number of teachers. When there were 50 girls, there were 20 teachers and 10 boys. How many boys were there when there were 10 girls and 100 teachers? There are two different ways to set up this problem. The first way I'm going to set it up is using the K constant. So it says that the number of girls varied inversely as the number of boys and directly as the number of teachers. So I'm going to have my girls equal to K times T. So G is my girls, K is the constant I'm going to look for, T is the teachers, and then that's going to be over the boys since they were varying inversely. And then the second way that we would set up this problem is using the ratios. So I would have the number of girls, and I'm using subnotation, so G sub 1 over G sub 2 would equal directly as the number of teachers, so that's T sub 1 over T sub 2. So see, this way, when it's direct, they're in the same order with the subnotation. But the boys was inversely, so we're going to flip that around. So I'd have the B sub 2 on top and the B sub 1 on bottom. So for the first method, we find K first. So I would fill in this information of 50 girls, leave the K because that's what we're going to find, 20 teachers, and 10 boys. Okay, then we can simplify this a little bit. 10 would cancel and only leave a 2 on top, and then I would divide by the 2, so 25 would equal K. And then I could go to the second part of the information where they're asking for how many boys were there when there were 10 girls and 100 teachers. So I can fill in the K value. So there were 10 girls, 25 is our constant, there were 100 teachers, but we want to find out how many boys there were. So I'd multiply by B on both sides, so I'd have 10B equals 2,500, and then divide both sides by 100. So the number of boys is 250. And we'll get that same answer by using the second method. In this method, you're able to fill everything in at once and then just solve immediately for the number of boys. So here I would have my 50 girls on top, and then my 10 girls on bottom. Then I would have, for the teachers, I would have my 20 teachers on top, and then the 100 on bottom. And then we're looking for how many boys, so that's the B sub 2 on top, and the B sub 1, that's the first amount of boys they gave us, which was 10, would be multiplied by the 100. Okay. So if I multiplied both sides, let's see, this would be just 1,000. I could go ahead and cross out that, so I'd have 2 over 100. If I multiplied by 100 over 2, or you could go ahead and simplify that further, then cancel, so this all cancels out, so I'm left with just the boys, and then my 10 cancels here, so I'd have 500 divided by 2, or I could say that this was 50 times 5. Lots of canceling you can do to simplify that, but this would still be 250 boys. So either way you'll get the same answer, and sometimes one way is easier than the other depending on the information that you're given. Alright, let's look at the second problem. We have strawberries vary jointly as plums and tomatoes. If 500 strawberries went with 4 plums and 25 tomatoes, how many plums would go with 40 strawberries and 2 tomatoes? First, work the problem using the variation form, and then work it again using the equal ratio form. So we're going to have those two different ways of setting it up, just like we did before. Let me move that down so we have plenty of room to set everything up. Alright, so the first method, I have strawberries equals a constant times the number of plums and tomatoes. So we have 500 strawberries, then our constant k with 4 plums and 25 tomatoes. So if I go ahead and divide both sides by 4 times 25, which is 100, I know that my constant, k, is 5. So then I can fill that in for the k for the second part of the information they give us. So we're looking for how many plums would go with 40 strawberries and 2 tomatoes. So 5 times the number of plums times 2. So I can go ahead and multiply the 5 and 2, and that would be 10. So I'd divide both sides by 10. That cancels those out. So there will be 4 plums. Alright, and then we can set that up with ratios, and we'll get the same answer. So just the general setup, we have s sub 1 over s sub 2 would equal p sub 1 over p sub 2 and t sub 1 over t sub 2. Then we just fill in the information and we're able to immediately solve for the number of plums. So we start out with 500 strawberries, 4 plums, and 25 tomatoes. Then we have 40 strawberries, and we're looking for the number of plums, so that's p sub 2, and we only have 2 tomatoes. And we can go ahead and simplify this a little bit just to make the math a little bit easier. So this would be 50 over p sub 2 equals 50 over 4, and then if I cross multiply, I would have p sub 2 here and 4 over here, and then I would be dividing by 50, so those cancel, and then I'm left with the 4, so p sub 2 equals 4, and that is plums. So either way we set this up, we end up with the same amount of plums. So more than one way to solve these problems here. Alright, now third example here. Now we solved these before, but when we solved them last time we had rational answers. This time we're going to have irrational answers, so it's not necessarily all that difficult, it just takes a little bit more time. So what we're going to do is use substitution. So I'm going to solve for x on the first equation, so x equals 2y plus 3, and I'm going to fill that in for the x here. So I would have 2y plus 3 times y equals 6. Then I would distribute my y across, so I'll have 2y squared plus 3y minus 6 equals 0. And then you can try to factor this, but this one actually does not factor, but you always want to check and see if it will. This one doesn't factor, so we're going to use the quadratic formula. So y equals negative b, so it's negative 3, plus or minus the square root of b squared, so that's 9, minus 4 times a, which is 2, times c, which is negative 6, and that's all over 2 times a, so that would be 2 times 2, which is 4. And then we just need to simplify this. So y equals negative 3/4. I'm going to go ahead and separate that out just to make it a little bit easier later on. And then that's the square root of 57 over 4. And then what we would do is substitute that in for this y. So I have x equals 2 times negative 3/4 plus the square root of 57 over 4. So see, this is actually two answers in one. We've got the positive and negative version of that. Alright, and then we are adding 3. So I would distribute the 2 across. So x equals negative 3 over 2 plus the square root of 57 over 2 plus 3. And then I can add that 3 and negative 3 over 2 together. So x equals a positive 3 over 2 plus the square root of 57 over 2. So we have our two answers basically, because when I put in a positive, I'll get positive here, and when I put in the negative, then that would be negative. Okay, so I'll list those out together. Scroll down a little bit here. So for 1 point, I have positive 3 over 2 plus the square root of 57 over 2, and that's my x. And then my y is negative 3 over 4 plus the square root of 57 over 4. Okay, and my other point would be still a positive 3 over 2, but this time it would be minus the square root of 57 over 2. And then my y would be a negative 3/4, but this time it's negative square root of 57 over 4. So not a very pretty answer, but not too bad.